The voltage across a 0.2 millifarad capacitor was 20 volts until a switch in the circuit opened at time t equals 0, causing the voltage to vary with time as according to this equation. Did the switch action result in an instantaneous change in V of t? Well, the answer had better be no, and this is going to be important because capacitors cannot change voltage instantaneously. So capacitors cannot change voltage instantaneously.
Is there anything that can?
Yes, an inductor can. But an inductor cannot change current instantaneously. And capacitors can. So, to me, the whole fact that anything can is, how can it be really instantaneous? I mean, how can, okay. So capacitors cannot change voltage instantaneously. So we talk about 0 minus as opposed to 0. So 0 minus means everything right up to time t equals 0, and 0 plus is right at time t equals 0. So the voltage at 0 minus, so the voltage was 20 volts until the switch was opened at t equals 0. So the voltage at 0 minus was 20. So, but the voltage at 0 is governed by this equation. So the voltage at 0 is 60 minus 40 e to the minus 5 times 0 volts. And don't forget that e to the 0 is 1, so this is 60 minus 40, which is 20 volts. So no, it did not change voltage instantaneously. So did the switch action result in instantaneous? No. Did the switch action result in an instantaneous change in the current I of t? Well, it might have. We don't know yet. So that's not, we don't know. The answer to the A had better have been no, but we want to check it anyway. So before the switch action, our current was 0. So I at 0 minus is 0. So we know that. But I equals C dV dt. And, well, we might not know that. So I is C dV dt. So before 0, V equals 0. So dV dt is 0. So I is 0. So I is 0 before 0. Okay, so at 0, I equals 0.2 times 10 to the negative third times dV dt, so I need to take the derivative of this function here. So the derivative of that function, derivative of 60, is 0, so that's minus 40 e to the minus 5t times negative 5 from my chain rule. And so that's 0.2 times 10 to the negative third times 200 e to the negative 5t, which is 0.04 e to the negative 5t. And so at 0, I of 0 is 0.04 e to the 0, which is 0.04, which is 40 milliamps, which does not equal 0, which it was before. So did the switch action result in an instantaneous change in the current? And the answer is yes. So for a capacitor, you cannot have instantaneous change in voltage, but you can have instantaneous change in current. How much initial energy was stored in the capacitor at t equals 0? This is an easy question. You hope you get one of these on the test, because the energy for a capacitor is just 1/2 CV squared, and we know V, we know C. We're going to just plug this in. So that's 0.5, and C is 0.2 times 10 to the negative third, and our voltage at 0 was 20, so 20 squared, and don't know that I did that. Yeah, it looks like I actually did not do that out, so hold on. I've got the calculator. So 0.5 times 0.2 to the negative 10 to the negative third times 20 squared is 0.04. 0.04 joules. Okay, how much energy will be stored in the capacitor at t equals infinity? Well, we have a function for the voltage of our capacitor, so it's being driven by something. It's not necessarily going to discharge all the way. So I need to take a look at it, e to the minus 5t, and figure out what, as t goes to infinity, what is my voltage? So as t goes to infinity, something raised to a negative infinity is 0. So if I plug in infinity here, 40e to the negative 5 times infinity, that goes to 0. So that gets me 60. So V at infinity is 60. So what's the energy? U equals 1/2 CV squared. That's 1/2 times 0.2 times 10 to the negative 3 times 60 squared. And I have written down that that's 0.36 joules.
Oh, you take a limit there.
So I think there'd be more energy after the open switch, like after.
Well, because we have this function, something is feeding it. Before, it was just sitting there. Now we have this function that is, it's going to, this part of it says, the 60, says it's always got 60 volts. Now, you're subtracting some off at the beginning, but as t gets bigger, this part goes away. So the switch actions basically is saying, I'm turning on a battery with 60 volts. So that's how I have more. And then not only that, that makes sense then that infinity, my capacitor, will also have 60 volts.